Astronomers have accurately measured the size of the remote dwarf planet Eris for the first time. They caught it as it passed in front of a faint star, using the Belgian TRAPPIST telescope at ESO's La Silla Observatory, along with two other telescopes in Chile. The new observations show that Eris is an almost perfect twin of Pluto in size. Eris also seems to be extremely reflective, probably because it is covered in a thin layer of frozen atmosphere.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
In this episode, we're going to look at new observations of the distant dwarf planet Eris as it passed in front of a background star, an event called an occultation, and what these results have revealed. Occultations are rather like eclipses. The background star disappears behind the object and reappears on its other side. As viewed from Earth, the brightness of the background star suddenly drops and then returns equally suddenly to its previous level. By looking at these two events, astronomers can measure the size and shape of the occulting foreground object. If they also know the mass of this object, they can then determine its density. Occultations of stars by distant objects in the solar system are very hard to observe because of the small size of the objects. But occultations are often the only way to learn about these remote specks, as they are too distant and too small to be seen as anything more than faint points of light, even through powerful telescopes. The occultation technique has now enabled astronomers to learn a lot more about the dwarf planet Eris. Eris was identified as a large object in the outer solar system in 2005. Its discovery was one of the factors that led to the creation of a new class of objects called dwarf planets, and the reclassification of Pluto from planet to dwarf planet in 2006. Eris is 3 times farther from the Sun than Pluto at the moment, and until now was believed to be about 25% bigger. But the new observations show that Eris is in fact almost exactly the same size as Pluto, with a diameter of around 2,330 kilometers. Because Eris also has a moon, called dysnomia, astronomers have also been able to calculate the mass of Eris by a careful study of this moon's orbit. Using the new diameter and known mass, they then calculated the density of Eris, which now appears to be greater than astronomers had previously thought. Eris seems to be a rocky body surrounded by a thick mantle of ice. The dwarf planet turns out to reflect almost all of the light that falls on it. Its surface is even brighter than fresh snow on Earth. Eris is probably covered in a very thin layer of frozen atmosphere that is likely to consist of frozen nitrogen mixed with methane. It is probably the result of the freezing of Eris's atmosphere as the dwarf planet's elongated orbit takes it far away from the Sun. These important new observations, made with relatively small telescopes, have allowed astronomers to measure Eris's properties better than ever before. This is another step towards understanding the mysterious objects that lie in the remote parts of our own solar system. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
Not long ago, actually watching something being ripped apart as it falls towards a giant black hole would be science fiction. But this is becoming reality for astronomers using ESO's Very Large Telescope. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Hello and welcome to the ESOcast. In this episode, we will see how science fiction has turned into science fact, as astronomers observe the progressive destruction of a cloud of gas that's being pulled in by a supermassive black hole. ESO telescopes have been used to track the motion of stars around the giant black hole at the center of our galaxy for 20 years. This black hole's mass is a hefty 4 million times that of the Sun, earning it the title of supermassive black hole. Although it is huge, this black hole is currently supplied with little material and is not shining brightly, but this is about to change. Using ESO's Very Large Telescope, a team of astronomers has discovered a new object that is heading almost straight towards a black hole at vertiginous speed. The object is not a star, but a cloud of gas.
The cloud consists mainly of hydrogen gas which we see anyhow in the galactic center all over the place. This particular cloud weighs more or less 3 times the mass of Earth, so it's a rather small and tiny blob only. But it glows very brightly in the light of the stars which are surrounding the cloud.
As the astronomers watched, the cloud has been picking up pace as it gets closer to the giant black hole. Its speed has doubled in the last 7 years, and it is now speeding towards the black hole at more than 8 million kilometers per hour. The astronomers have already seen the cloud's outer layers becoming more and more disrupted over the last few years as it approaches the black hole. But the exciting part is yet to come.
The black hole, imagine it sitting here, has a tremendous gravitational force, and the cloud, as it comes in, it will be elongated and stretched. It will become essentially like spaghetti. It will be elongated and falling into the black hole.
Well, the next few years will be really fantastic and exciting because we are probing new territory. Here this cloud comes in, gets disrupted, but now it will begin to interact with the hot gas right around the black hole. We have never seen this before.
No one knows what will happen next. The cloud will probably heat up and may start to emit powerful X-rays as it gets disrupted. In the end, the material will eventually disappear by falling into the black hole. For the scientists, this event is truly a unique chance to probe the hot gas around the black hole.
But this process of how material gets into black holes really is not clear to us. We don't understand it in any detail. And here in the galactic center, we have an opportunity, so to speak, to have a probe of this process, how material really gets added to the black hole and what the physical processes are, how the interactions happen in this very central region. That's a fantastic opportunity.
This is indeed science fiction becoming science fact.
Alma, the world's most complex ground-based observatory, has just opened for business. The telescope is still being built, and its capabilities will continue to grow over the coming year. But even at this early stage, its images reveal a view of the universe that is invisible to normal telescopes. Thousands of scientists from around the world have competed to be among the first to use Alma. With it, they hope to explore some of the darkest, coldest, furthest, and most hidden secrets of the cosmos.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In this episode, we'll get the latest news from Alma, the Atacama Large Millimeter Submillimeter Array, as it begins its first science observations, and we'll reveal the first public image from Alma, a dramatic view of galaxies that are undergoing a cosmic collision. We'll find out how astronomers around the world have been eagerly waiting to get their hands on this revolutionary telescope, and discover why this is only the beginning for the observatory. So far, only around a third of Alma's 66 antennas have been installed at the observatory site on the Chajnantor Plateau, 5,000 meters up in the Chilean Andes Mountains. And yet, even before it's completed, Alma is already the most powerful telescope of its kind. Alma observes the universe in light with millimeter and submillimeter wavelengths, roughly 1,000 times longer than visible light wavelengths. Using these longer wavelengths allows astronomers to study extremely cold objects in space, which appear dark through normal telescopes. In addition, they are also very useful for peering inside dense clouds of cosmic dust, and for observing very distant objects in the early universe. Alma is radically different from visible light and infrared telescopes. As well as looking at these longer wavelengths of light, it works in a totally different way. Instead of being one big telescope, Alma uses an array of antennas spread out over distances of up to 16 kilometers. The views from each antenna are combined into one image by one of the world's fastest special-purpose supercomputers, the Alma correlator, which can perform 17 quadrillion operations per second. Because of this, pictures from Alma look quite unlike more familiar pictures of the cosmos. The Alma team has been busy testing the observatory's systems over the past months, in preparation for the first round of scientific observations. One outcome of their tests is the first image published from Alma. This image was made using only 12 antennas, fewer than will be used for the first science observations, let alone the completed observatory, and spaced much closer together as well. Both of these factors make the new image just a taster of what is to come. The antennae galaxies are a pair of colliding galaxies with dramatically distorted shapes. While visible light shows us the stars in the galaxies, Alma's view reveals the clouds of dense cold gas from which new stars form. Massive concentrations of gas are found not only in the hearts of the two galaxies, but also in the chaotic region where they are colliding. Here, the total amount of gas is billions of times the mass of our Sun, a rich reservoir of material for future generations of stars. Observations like these will be vital in helping us understand how galaxy collisions can trigger the birth of new stars. This is just one example of how Alma reveals parts of the universe that cannot be seen with visible light and infrared telescopes. Over the coming year, The sharpness, speed, and quality of its observations will increase dramatically as more antennas become available and the array grows in size. But even with only part of the array in operation, this is already the best sub-millimeter wavelength image ever made of the antennae galaxies. Alma could accept only about 100 or so projects for this first 9-month round of observations. Nevertheless, over the last few months, astronomers from around the world have submitted over 900 applications to use it, a record level of interest. The successful projects were chosen based on their scientific merit, their regional diversity, and also their relevance to Alma's major science goals. Let's hear from some of the astronomers who are planning to use Alma and why they're so excited about this new telescope.
One of the main reasons we're building Alma is to study the birth of the solar system, in essence. The solar system was formed 4.5 billion years ago, and we'd like to understand how other solar systems have come into being. And Alma's got the scale, the sensitivity and the resolution to make detailed studies of solar systems like our Sun forming nearby in our galaxy.
I look at molecular clouds in nearby galaxies. Molecular clouds are where stars form. The clouds are made up of very cold gas, and studying the physical conditions in these clouds helps us to understand the star formation process. Currently we can study molecular clouds only for very nearby galaxies, out to about 30 million light years. With Alma we'll be able to study individual clouds in galaxies much, much further out.
Alma is going to be a very important instrument to teach us about the physics that go on around the black hole in the centre of the Milky Way galaxy. This is because all the intervening dust can obscure some of the shorter wavelength observations. So at the very high angular resolutions and into the sub-millimeter band that the Alma telescope will be able to observe at, we'll be able to look at the fine scale structural detail around the black hole.
Well, we know of some galaxies that exist in the Faraway universe that are only seen in certain wavelengths. So, for example, we know about radio galaxies that are not observed in any other wavelength, even with the most powerful telescopes. And we have been waiting for Alma to give us the possibility to understand what these galaxies are and what is happening in them.
Building work by Alma's partner organizations from Europe, North America and East Asia will continue during the first science observations. By 2013, the observatory will be complete and will feature 66 antennas spread out over distances of up to 16 kilometers. By unfolding its enormous observational potential, Alma will revolutionize many areas of astronomy and will provide us with profound insights into the universe. This is Dr. J, signing off for the ESOcast. Join us again next time for another cosmic adventure. On Saturday, 15th of October, ESO, the European Southern Observatory, opened the doors of its headquarters in Germany to the public. Throughout the day, thousands of visitors had the chance to help build a full-size mock-up mirror of the largest planned telescope in the world, the European Extremely Large Telescope, or EELT. and to experience many other aspects of ESO's work.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
ESO's 2011 Open House Day attracted around 3,100 visitors to its headquarters in Garching near Munich, Germany. The visitors were curious to find out more about ESO's world-class facilities and frontline scientific results. Participants had a wide variety of activities to choose from, with the highlight of the event being the construction of a life-size cardboard mock-up of the EELT's giant 39.3-meter mirror. This gave participants a unique chance to experience the true scale of the world's future biggest eye on the sky. Because the EELT's main mirror is so large, it consists of 798 individual hexagonal mirrors, each about 1.4 meters across. Using pegs and an outline of the mirror on the ground, enthusiastic visitors of all ages placed the cardboard hexagons on the ground to slowly form the giant mirror. When finished, the full-size mock-up measured 39.3 meters across and occupied an area of nearly 1,000 square meters next to the ESO headquarters. Additionally, there were talks on hot topics in astronomy and video links to the Very Large Telescope, giving people the opportunity to chat live with ESO astronomers working on Cerro Paranal in the Chilean Atacama Desert. Children and their parents enjoyed having their photos taken in infrared light and observing the sun through telescopes equipped with suitable filters. 3 exhibitions were dedicated to ESO's Very Large Telescope, the Atacama Large Millimeter Submillimeter Array, and the future EELT. Once again, the Open House Day at ESO was a great opportunity for people to discover the latest exciting developments from the world's most productive astronomical observatory. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.